All right, hello. Welcome to my channel. This is an educational channel where we talk about mostly different theories of everything that I think that the general public could benefit from if they knew anything about them, which they probably don't, because these are pretty obscure and esoteric theories of everything. Today is video 227 on the reciprocal system of theory. And the reciprocal system of theory is theory of everything that was first promulgated by Dewey B. Larson back in the 20th century. He worked on it up until his death in 1990, put out a lot of great books and articles, and some of his work has been carried forward by other people, and we will be looking at some of that today. The basic idea behind the reciprocal system is that we live in a universe of motion. The universe is not made out of matter, it's not made out of energy, it is made out of motion. And for Larson, motion is the relationship between space and time. And that sets up a generalized reciprocal relationship between space and time. Motion is basically a fraction that has either space or time as the numerator and either time or space as the denominator. And time or space can both be in 3 or more dimensions, what Larson refers to as coordinate space and coordinate time, XYZ coordinates of space. We are familiar with that, but the coordinates of time, something that we're not as familiar with. Then also there is what Larson calls clock space and clock time. Clock time we're familiar with. The clock is always getting later and later and later. This is a motion, but it's a motion that has no particular direction. It has a magnitude, but no direction. That's what Larson calls a scalar motion. And we recognize that in the clock, but it also refers to the clock of space. Space is always getting later and later and later. I'm sorry. Space is always getting farther and farther and farther apart. And that is what Larson calls the progression of space. You can envision this with a balloon and a magic marker. You put a bunch of dots on the balloon, you can blow up the balloon, and all the dots move away from each other, but in no particular direction or in all directions. This is a scalar motion and the progression of space. Then also space and time both come in only discrete units. There is a minimum unit of space and a minimum unit of time. Less than that does not exist. So you have to have at least one unit to have anything. Those units are very small, but they are, they do exist. And what exactly one unit of space in one unit of time, space per time, that's space over time, and that's speed or velocity, space over time. And exactly one unit of space in one unit of time is the speed of light. So the speed of light in Larson's system is really like the midpoint of the universe, where there is an entire half of the universe that's moving faster than the speed of light. Larson calls this the cosmic sector, and this sector is largely unknown by legacy scientists. The material sector, the sector that's moving slower than the speed of light, is known by legacy scientists through their observations and measurements, and it is mapped out pretty thoroughly. But we can extrapolate what we know from the material sector to the cosmic sector simply by reversing the roles of space and time. And so, for example, in the material sector, you have coordinate space, 3 dimensions of space, and clock time, the progressing clock, always getting later and later and later. That is what you get in the material sector. In the cosmic sector, you get coordinate time and clock space. So you have 3 or more dimensions of time, and it's progressing through space. Maybe a little bit hard to imagine, but work on it and become used to that concept, and it will pay you back. Okay, now what we're looking at today is this is the 3rd episode where we're looking at an article written by Daniel Phoenix 3. These are part of the Daniel Papers, and Daniel is a pseudonym for Bruce Perret, Dr. Bruce Perret, who recently passed away about 3 years ago. And he is one of the great revisers of Dewey Larson, corrected a few of Larson's mistakes. Now, I would say no mistakes in the reciprocal system, but in the application of the reciprocal system, that is where Larson admitted that he was prone to make a mistake, or possibly made a mistake or two, and that those mistakes would eventually become apparent. So Perret has noticed a few mistakes that Larson's made. He's also extended Larson's theory into some other fields, including anthropology. And that's what we're talking about here. This is his first paper on anthropology called Geochronology. Daniel is a person who apparently worked on the Montauk Project, or the Philadelphia, part of the Philadelphia experiment. A lot of time trial stuff, secret black ops of the government from the 80s. And Daniel claims that he was one of the young computer programmers that worked at this place out in Long Island. And don't know if that's true or not. You can compare notes with him and Al Bielek or Duncan Cameron or the other guy, and maybe see. But we are about to start a section here that is called Growing a Planet with Expansion Tectonics. The current geometry of the Earth is an oblate spheroid, a flattened ball, of fixed dimensions on which exist continental plates that slide around and bang into each other an inch or two a century, creating mountains, valleys, earthquakes, and volcanoes. The science is called tectonics and is the result of the standard scientific approach of trying to create a theory to explain observation. Let's take Larson's approach and use the concepts of the reciprocal system to determine the inner structure of a planet and find the natural consequences of that structure. An initial draft of this research was published in Perret's 1998 paper, At the Earth's Core, The Geophysics of Planetary Evolution. Okay, so Daniel is referring to a paper from Perret. That's Daniel's own paper that he's referring to. These two people are the same. So Perret's 1998 paper, At the Earth's Core, The Geophysics of Planetary Evolution. It proposes a planetary model that is based on the remnants of a white dwarf star, the B component of the common red giant white dwarf stellar binary. The idea is explained in detail by Larson in Universe of Motion, Larson's book on astronomy, where the A component, the giant star, reaches its age limit early and explodes in a supernova. What Larson failed to consider, and what Perret points out, is that the B component, white dwarf, sitting in close vicinity to a supernova, is unlikely to survive the explosion and will be destroyed in space and accelerated into time, producing a number of small, super dense fragments that evolve into the cores of planets. Now that we know we're sitting on a white dwarf core, Larson's research on white dwarf stars provides a roadmap to understanding what is going on beneath our feet. The reciprocal system demonstrates that the same processes occur over and over in nature, just at different scales, so knowledge obtained from quasars or galactic implosions can be used with white dwarf stars, stellar implosions, planets, which are dwarf fragments, asteroids, which are smaller dwarf fragments, all the way down to atoms and particles, which are also just motion in time located in space. The planetary interior, like its stellar parent, is divided into 4 distinct layers based on the concept of motion and how many dimensions of that motion exist in either space or time, what Larson refers to as the astronomical speed ranges. He's got a little graphic here where he's got the different cross sections of the flattened spheroid that he says that the Earth is shaped like. And we've got the inner. We've got the asthenosphere, or the crust, and then we have the mantle. That is 1 minus x speed, and then that's inward in space, or gravity. And then we have the inner core. Well, first then we have the outer core, 2 minus x. That has an inverse density gradient. And then we have the inner core, which is 3 minus x, outward in space, like so. Anti-gravity, like so, outward in space. And then we have the inner core, which is in time, 1 minus x in time. That actually, for the first time, that actually makes sense to me this time. So it's a feather in my cap. It might not help you, but it just shows that, you know, you have to go over this stuff over and over and over again until it clicks. This is difficult, abstract stuff, but if you do enough of studying of Larson and his work, and Perret as well, it's consistent, and you might not get it the first time or 2 or 3, but eventually something will click in, because they're using the same methods and the same techniques to drive everything. And so you just have to kind of understand what they're doing, and then somehow it begins to make sense. Okay, so he's going to explain these zones that we just went through. Each of these speed zones has specific attributes that contribute to the behavior of the planet. 1 minus x. Perret actually refers to it as 1 to x, but I believe it's 1 minus x, because that goes along with the discrete unit postulate. This is less than one unit of speed, less than the speed of light, 1 minus x, whereas 2 minus x If 2 is a number between 0 and 1, 2 minus x means that it is a greater than the unit speed, but less than 2. And then 3 minus x also greater than twice unit speed, but less than 3 times unit speed. Okay, so 1 minus x, low speed range of normal matter that comprises the cyalic or continental crust, the cymatic ocean bed crust, asthenosphere, slippery magma layer, and mantle. The mantle is part of the original dwarf star remnant, whereas the crust is composed of meteoric aggregate. The mantle exhibits the property of inward motion in space that we call gravity. So the crust is coming from meteoric aggregate. So basically, meteors that have crashed into Earth create the crust of the planet, but the mantle is left over from the white dwarf. Okay, 2 is 2 minus x, intermediate speed range, where 2 dimensions of motion exist in space and 1 in time. This forms the outer core that has an inverse density gradient, which means that it's like a hollowed shell. All of the densest matter is at the surface, while the interior is tends to be hollow. So that's the density is inverse how you would normally the center is the most dense and the periphery is less dense. Here with the inverse density gradient, you have all of the matter congregating at the surface, and the center tends to be hollow or less dense. Inverse density gradient, where the shell of the outer core contains the densest materials with a light gaseous lower region. Since gravity requires all 3 dimensions of motion to be inward in space, and the outer core only has 2, it exhibits neutral gravity. Because of this presence of motion in time, the outer core produces an immense scalar magnetic field. Okay, then we have 3 minus x, ultra high speed range, where 1 dimension remains in space with 2 in time. This forms the inner core and exhibits anti-gravity motion, as well as other properties associated with the pulsar. It is the balance between the gravitation of the mantle and the anti-gravitation of the inner core that keeps a planet in a stable orbit, much like trying to go up the down escalator. At the same speed and end up going nowhere. Up the down escalator at the same speed and end up going nowhere. Okay, and then for 1 minus x in time. Inverse low speed range, where all motion is in 3D time. This is the inner core that was only recently discovered by geophysicists named Mehran Keshe as the Caroline core. This appears as an empty bubble-like void at the very center of the inner core that creates a link between the spatial and temporal structures of the planet, and when considered in a living aspect, would form the soul of the world. Okay, trying to see where we are time-wise. I think we have a couple minutes still. Because of the faster than light motion involved in a white dwarf star, the core exhibits conditions that are the opposite to a normal star. Rather than increasing in density and heating up, the white dwarf decreases in density and cools down, creating an inverse density gradient in the core of the planet. Due to the drop in density, the core expands over time, cracking the mantle and the crust sitting on top of it, creating the observed tectonic plates. However, like their stellar counterparts, the white dwarf cores do not just slowly expand, they expand in discrete stages analogous to the solar transition, remaining quiet for centuries, then, when reaching a critical level of compression, fracturing the mantle, expanding the planet, and splitting the crust along the tectonic fault lines. Because of the increased surface area, those plates are free to slide around on the asthenosphere, a slippery magma layer that exists between the crust and the mantle. The plates will then come to rest at their least energy configuration, which is usually a 90-degree rotation, bringing the massive weight of the ice caps to the equatorial region, like adjusting the clothes in an out-of-balance washing machine. Note that the mantle inner and outer cores have not moved. The crust just slides relative to the magnetic poles, so it appears that the poles are bouncing around on the surface. A simple way to understand this expansion is to take a balloon, inflate it, then cover it with mud and let it dry. Now inflate the balloon some more and watch what happens. The cracks in the mud become the ocean bed. The separate pieces of mud become the continents. As the balloon gets larger, there is more room for those chunks of mud to slide around on, giving the appearance of plate tectonics. Okay, now that is a pretty good model there for the plate tectonics. So there is more than one use for your balloon. You can use it to represent scalar motion with the dots on the balloon, and you can also use it to depict the continental drift using mud and then letting it dry. Okay, that'll do it for today. We'll be back and we will continue going over this article on plate tectonics and geochronology next time. Thanks for tuning in. Have a great day.